Hi, this is Gus Jansen at HiTechnic. In this video I'm going to demonstrate the new HiTechnic motor PID block. What this block does is it lets you control accurately the position of the motor. You should be considered an alternative to the standard motor block. Unlike the motor block where you would say drive for perhaps 45 degrees forward, maybe another 45 degrees forward, backwards 90 degrees. This one you just tell the motor what position you want to go in. Turn that on. Here's the first demonstration program. In this loop, I have 3 PID blocks with weights after them in a loop. The first PID block has been set up to go to a set point of minus 45 or negative 45 degrees using 100 power and wait for completion. Wait for completion in this case is important. It says don't go on to the next block in the program until you have reached that set point. Let's go ahead and download this and take a look at what it does on the robot. So you notice that the position that the motor started in became that 0 position. So this is minus 45, 0, 45. If I start somewhere else, it's going to do the same thing, but based on that start position. And that might be okay. For some things it might be okay. If you're having a wheel on a robot that moves, then you probably don't care exactly the position of the wheel. But if you have something like a robotic arm or a gripper or a selector, then you probably care about the motor position, the exact motor position. You want an absolute position. So there are different ways of doing this, of establishing a sort of reference for the position. What I'm doing here is I've put a mechanical limit. Now I'm just using a pin that this pointer hits. Your arm itself might reach a mechanical limit if you're doing this with a robotic arm, or you might have the gripper go all the way closed or all the way open for that reference. So there are different ways of establishing the reference. I'm going to add another HiTechnic motor PID block to the program, and I'm going to put it at the very beginning. I'm going to set C, output C, and then I'm going to say reset at forward limit. Now it's going to drive, that means drive forward until you hit the mechanical limit and then assign it the set point. Well, I don't want that to be the 0 position. I'm going to give it 85 degrees. So in other words, once you find the forward limit, assign that position to be 85 degrees. And then everything after that is going to be relative to that. We'll go ahead and download it and then run. So you saw, first thing that it did, doesn't matter where you start it, it's going to find the mechanical limit and then it's going to go into the loop and go between those 3 positions. Alright, now that was forward limit. There are several other resets. There's reset to backwards limit. That means go backwards until you hit the limit and then assign it. We can try that one really quick. I'm going to assign that one negative 265 degrees. So you saw it went all the way around until it hit the backwards limit, and then it assigned that so it has a reference, and then it went into the loop. One more of these mechanical limit resets. There is the midpoint of the limits. That means find both the forward and the backwards. I'm going to go ahead and give this one a 0 just so you can see what happens then. I'm going to assign a 0 angle to the midpoint between the limits. Forward limit, backward limit. So the midpoint is the point that's completely opposite the limit, and that's the 0. So 45, negative 45, 0, 45, and so on. Okay, so why use this instead of motor blocks? If you say motor forward 45 degrees, forward another 45 degrees, backwards 90 degrees, won't it do the same thing? Yes, it will, or at least something very similar. There is a certain risk that it will wander, but that basically does the same thing. But what if you don't know your current position? What if you just say, from wherever you are, I want to go to position X or position Y? In this case, I'm going to use those same 3 positions. I'm going to have minus 45 degrees whenever you press the left button, And if you press the enter button on the NXT, go to the 0 position, and the right button, go to positive 45 degrees. And I still have this reset in here to find that forward mechanical limit. Let's go ahead and try this. So the needle stopped here because in my loop, I'm not automatically going to any of those 3 positions. I have to press a button. So the middle button goes there. Left, right, middle. So you see, it doesn't matter where I'm currently at. It just goes to the position I'm telling it to go to. And if I stop the program, start somewhere else, it's still going to work perfectly because of that reference. Very simple program, very easy to establish absolute reference points for the NXT motor. Now there is one other kind of reset, and I'm going to show you right here. This one says reset at current position. Well, you can, in some situations, you don't have a mechanical limit. You want your motor to be able to drive essentially continuously all the way around, but you still want to have one of those positions to be a reference. So what I've done here is that I've added a touch sensor so that when this needle comes around, it will press the touch sensor, and I'm going to use that as a reference. Let's take a look at the program. I actually used the standard motor block here in the beginning and just tell the motor to go forward unlimited, fairly slowly. I'm using 30 power. And then I have a wait for the touch sensor, and I set it up to do bumped. That means that it has to get both pressed and released. That way it really makes no difference where you start it. And then once I hit this point, I do a reset at current position. So as soon as that gets bumped, the touch sensor gets bumped, it will reset the PID block and assign that to be 130 degrees. And then I go back into that same loop that I demonstrated before, going from minus 45, 0, 45. Let's go ahead and download this. So you saw it pressed the button and it actually went all the way past until it released it. And then if I start somewhere else, it will still do the exact same thing. Now in this demonstration, I'm just using angles like minus 45, 0, 45, and you can use any angles. You can say 1,000 degrees, 10,000 degrees, whatever, positive or negative, and it will go to that location. It will spin as many times as it has to get there. One final demonstration, and that is I'm going to put it together with the angle sensor block. Now I was using wait for completion, that option checked, but you can, sometimes it's better to have that option cleared. I'm going to set up so that my 2 pointers point pretty much parallel. And I'm going to download and run this program. So let me talk really quickly about what this program does. The first block resets the accumulated angle of the angle sensor, and then inside the loop I read the accumulated angle and then I pass it to the set point of the PID block, and the wait for completion is cleared. That turns out to be important. Okay, let's take a look at what it does. Notice that in the loop, it's very quickly reading the angle sensor, the accumulated angle, and then it passes that directly to the PID block, which makes the motor it gets there as quickly as it can to the whatever position it tries to get you're setting the set point to, with very little overshoot, and it's very powerful. I'm almost putting no effort into the angle sensor, but the motor is using up to 100 power. So if you had something heavy on there, no problem. It would just go there. I hope you find this block useful. Feel free to use it in all your programs. It is, right now I'm using it with just one motor. You can use it with 2 or 3 motors at the same time. You can either have your PID blocks one after the other inside the loop, if you want to do something like what I'm doing here, or you can have parallel loops, and it will work either way. The block is said to be thread safe. It works even if it's being called by multiple threads at the same time. Enjoy!